Hi everybody, here we are in the living room of my house and we're going to go over the solutions to this practice test here. First problem, the equation is already given to you in center radius form, so it's just a matter of kind of reading the equation. So x plus 5 means the x coordinate is -5, y minus 3 means the y coordinate is 3, and 64 means the radius is the square root of that, which is 8. Next problem is not given to you in center radius form. And so I converted it by completing this square, by kind of moving the terms around a little bit, and I get half of that gives me 49, half of that gives me 9/2, which when I square it is 20.25. So there's all my y terms together after completing the square. Of course, I add the same thing to the other side of the equation to keep it all balanced. And then this is my center radius form. So when it's in that form, it presents to you the center is 7, -9/2, and the radius is the square root of that number, which is 8.5. Okay, Frankie and Johnny on the Axis Highway. Frankie's going north, Johnny's going south. Johnny rides a little bit faster, about 1.5 times as fast as Johnny, and so we're asked to find Frankie's speed, so we'll call that S, Frankie's speed. 1.5s is then Johnny's speed. Okay, and we're given that the total time is 45 minutes, which I've converted into hours, 0.75 hours, and they say that the whole trip was 15 miles, okay? So that's the whole trip, and remember, distance does equal rate times time. So what we want to figure out is how far did Frankie go and how far did Johnny go? Well, the distance equals the rate times the time. So Frankie's distance is 0.75 times s, 3/4 of an hour, that's the time, times s, his speed, or her speed, actually. I'm not sure if it's Frankie's a boy or a girl, but anyway. And then the same kind of an equation for Johnny's distance, which is, there's your time and there's your rate. It works out to 1.125 times s. And so the two distances together add up to 15 miles, and that's kind of the key little part of writing the equation, is seeing that. Well, when you do that, the equation is pretty simple, and you get that Frankie was riding the bicycle at 8 miles per hour. Okay, moving on here, solving some equations. Here's this equation worked out. Here is the solution from -infinity to 7/5 union 3 to infinity. Now, keeping in mind that I cannot let x equal 3 because that would make the denominator undefined, but I can let the numerator show. Here is how that problem kind of simplifies down, in case you want to see that. When I move the 2 over to the other side and combine my fractions together, multiplying the 2 times x minus 3 over x minus 3, I get this, which simplifies down to 5x minus 7 over x minus 3 is greater than or equal to 0. So that's where I get the number for the top is 7/5, and the number for the bottom is 3. So that's what gets put on the number line, and those are my critical values. The next problem is a little bit simpler because it's presented already in factored form. So we have -1/3 from this factor and +1/2 from that factor. Testing gives me less than 0 in between those two values, so there's my solution interval right there. I want less than 0 for this one. The next one, next inequality, it's a quadratic inequality, but it's not factored, so you had to do that little bit of work there to factor it. It factors like this, and again, we're looking for greater than or equal to 0 in this one, which means I want the regions that are positive. And so my 3/2 and +5, I test those, and these are the regions. So my solution then is from -infinity to 3/2 union 5 to infinity, including both of those values there, because of the greater than or equal to sign in the inequality. Okay, next problem about Holden-Fowler's. Just the perimeter of the rectangle there is 160 feet. There it is, 160 feet, and the width is the length is 4 times as long as the width. So if that's x for the width, then that would be 4x for the length. Adding all of those sides together gives us the equation 10x equals 160, and so that means x equals 16 feet, and the pen is 16 by 64 feet. Let's move on. Solving some equations here. Okay, here's an equation with with some fractions in it, and we had to bust those fractions by multiplying by the lowest common denominator, which would be 5 times x minus 3. It's three things multiplied together. This 5 is a factor of that denominator, so I don't have to have 5 times 5. It's already included. When I multiply this first fraction times this common denominator, the x minus 3 gets canceled out, and I'm left with the 5x times the numerator of 6. That same kind of thing happens for each of the other parts of the equation. Here the 5 will cancel out, leaving behind the x times x minus 3. So that's why I'm multiplying that numerator of 3 by. And then same thing over here, leaving me 4 times x minus 3. When you work all that down and work it out, you get this quadratic set to 0. And using the quadratic formula, that gives me this value right here. Okay, so that's just using the quadratic formula on that. Part B is a radical equation, and so what you have to do is you have to isolate the radical, okay, and then square both sides. You cannot square both sides until you isolate the radical, and most importantly, you cannot square individual parts of the equation. You have to square both whole sides. So when you isolate the radical, you get x minus 3 on the right side, and you square that, you get x squared minus 6x plus 9. Over here we had 5 minus x. Sending it to 0, giving us a quadratic, and then factoring the quadratic to find the solutions, we get x equals 4 and x equals 1. However, I cannot use x equal 1 because when I check that solution in this equation, all right, letting x equal 1, I don't know why it won't focus, I'm sorry about that. Square root of 5 minus 1, that's 4, and the square root of that is 2. 2 plus 3 does not equal 1, and that's a problem. So I can't use x equals 1. 4, however, checks out. No problem. 4 is fine. So we got an extraneous solution right there for that problem. Let's move on to part C. All right. Here's an equation in quadratic type. It's not a quadratic equation, but it is in quadratic type. That's 2x to the 4th minus 7x squared plus 6 equals 0. It factors like a quadratic. You get your solutions. 2x squared minus 3 is 0. So x squared equals 3 halves, and x is plus minus a square root of 3 halves. Over here, x is plus minus the square root of 2. All right, the last problem in this group is another one with fractions in it, and same process as the first one. Boils down to this here quadratic, 5x squared plus 6x minus 3 equals 0. And I'll just show you that that one does go a little bit further than the first one as far as simplifying goes. I get the square root of 96, which I can write as 4 times square root of 6. 6 times 16 equals 96. So I can pull out that 16 factor. Square root of that is 4. So that simplifies down to this fraction right here. All right. And the next problem is this problem right here using the slope-intercept form of the equation of the line. For the next two problems, okay, so I want the center of that circle, which when I work it out with completing the square form, gives me 4 1/2. And so I need to find the equation of the line through that point and 0, 0. Just a little picture of that means that I can see that my slope is up 1/2 and over 4. That gives me a slope of 1/8. So my line is y equals 1/8 x. The next line, next problem, I'm trying to find the equation through this point that's perpendicular to that line. And if you remember your perpendicular slopes, that is a 5 over 4 there, which means that you take the opposite reciprocal of 5 over 4, which is negative 4/5. So that's my perpendicular slope. And I want it to go through the point 5, 2, so I'm going to use the point slope form to start off. So y minus 2 is equal to negative 4/5 times x minus 5, which, with a little bit of work, simplifies down to y equals negative 4/5 x plus 6. And the very last problem in our solutions here is using interval notation to describe where this graph is less than or equal to 0. Well, it crosses the x-axis right there at positive 1, and then it's going down below that from to the right forever. So our interval is from positive 1 to infinity. Okay, that's the solutions. Stay tuned. There'll be another practice test here pretty soon. Bye.